Hi again. This is the second recording, and as promised, what we're going to do here is to prove the main theorem. So this is actually the theorem that Victory, Clark, and Groves independently of each other in different contexts, where you could say special cases of the setting that we are considering found. And we're going to look at the proof for the setting that we are in. So what we're going to do is to prove this theorem stated over here. So under the VCG mechanism, reporting the truth, that is Ri Vi is equal to Vi for all Vi, is a dominant strategy. That is one statement. And the second statement is that if we do that, if everybody reports the truth, then allocation is efficient. And it's the easier part is the second part. That's the most important part, because it says that if we use VCG, then allocation is efficient. So that is actually what we want to achieve. But the difficult thing to prove is the first part. And once you have that, then the second one is straightforward. And so because, because what? Well, because the VCG mechanism itself is maximizing total reported valuation, right? So the B star that VCG selects maximizes total reported utility. But of course, if people report the truth, then total reported utility is equal to total true utility. And so that is then also maximized. So that's easy. The difficult part is the first part, to prove that truthful reporting is a dominant strategy. So we're going to look at that. So how do you prove that? Well, you have to prove that it is a dominant strategy. That means that you suppose that you are agent I, right? So you put yourself in the shoes of one of these agents. Suppose you're agent I. And you know your valuation is in fact VI. So now you have to decide whether you're going to report that or not. So what you can do is to simply take a certain report and see what the effect is of that report in the current situation. So let's say the situation is R minus I, so all the other people make a certain report. Doesn't need to be truthful, right? So they can do whatever they want. Dominant strategy means that no matter how ridiculous the other one's bid, my bid is still maximizing my personal utility. So you just take any report of the other ones, ridiculous or not, truthful or not, doesn't matter, just any report. And we're going to argue that reporting VI is best response. So how do we do that? We just take any report Ri. And yeah, so how does my utility now look like? Well, so the mechanism is now going to choose two allocations, AB that maximize the total reported valuations, and BI that maximizes total reported valuations of my opponents, right? So those are the two that are chosen, the B and BI. We start them in the initial one, but here we don't know what the reports are, so let's do it like this. At least these two are chosen. And then my utility is given by, well, it is, so the utility is now given by my valuation, right? The true one, because B is chosen. And this is how I truly evaluate that. Subtracted my payment. And the payment is given by this externality, given the reports. So that looks like this. You can look up the formula. Right, so it's a difference between the BI, the sum of the BI, so the maximizer for report valuations for J other than I, and you subtract what they get under B. So now you can actually reorganize that a little bit. So what it says here is that this is, in fact, so maybe I should rewrite that. Yep. Like this, right? So I didn't do much. I just multiplied out, and we get this. And in some sense, this is already the proof. I guess you do not see that immediately, but you see this part over here, the second part, actually does not depend on your report. I'm still agent I, right? And I report this particular RI. And my claim is that this expression over here does not depend on, of course, the RJs do not depend on RI, but what is more important is also that this BI over here. So the way the allocation is chosen in the mechanism also does not depend on RI, because the BI only depends on profiles of opponents. So this is, for all I care, a constant, right? And I don't know what it is, so it might be a large number, or it might be negative or positive, and I may be happy about it or not, but one thing is for sure, I cannot avoid it, right? It is what it is, whether I'm happy with it or not, but I can't change it. So the only thing that I can influence with my bit is this part over here. This I can influence with my own reported valuation, but also only to a limited extent. Namely how? Well, VI is simply what it is, right? So this is how I truly think about the world. And also there I cannot change who I am. And so my reported valuation does not affect how I really think things should be evaluated. And also these RJs are chosen by my opponent, so I can't influence them. The only thing that I can influence is this B. And yeah. So what does this B maximize? So this B maximize total reported valuation. So that is the sum over all J and N. RI B, which is, if I rewrite that, so this part here is equal to, well, this RI of B plus sum not equal to J, or J of B. And that's nice, because what does that mean? It means that so this B is chosen in such a way that it maximizes this expression over here, which is the same as this expression over here. So the B is chosen to make this expression as large as possible. And what do I want it to do? Well, I want it to maximize this expression, right? Because that's my utility. So I want the B to maximize this expression over here. What in fact it does maximize is this expression over there. And so you see the difference is not very large. The only difference is that here it says VI and here it says RI. So how can I now align what the mechanism does with what I want it to do? Well, simply by reporting RI is VI. And that is the proof. right? If I report Ri as Vi, then the mechanism is going to maximize exactly the expression that I wanted to maximize, namely VIB plus the sum over J other than Rj. And that's the proof. So you see that no matter what the others report, reporting the truth is always a best response. And so I wanted to maximize this expression and it maximizes the one below. And if I report Ri as Vi, then these are identical. Okay, so that is the proof. There is a third part to this lecture, which is about, you could say, a specific application of VCG to one item. You could say the setting that we've already seen, one indivisible item, and we're going to talk a little bit about that. But also that we will do in a next recording. So see you there.